what's called simplifying or solving trigonometric identities, which is, it's kind of different from what we've been doing. There's less focus on the unit circle, but all of these identities are formed from the unit circle. So, for example, like we know sine is the opposite over the hypotenuse. This could be considered a trig identity because it's dealing with an equal sign. All right, well now they're asking us about cosecant. So far when we've talked about cosecant, I've told you I know it's the reciprocal of sine. And so we've been writing it as the hypotenuse over the opposite. Well, another way you could say that, if it's the reciprocal of sine, we can write it as 1 over sine. Because that's what a reciprocal is. So that's what these first identities, they're fill in the blank. You can see cosecant of theta is 1 over what? It would be 1 over sine theta. Secant of theta would be 1 over cosine theta. And cotangent of theta, 1 over, that seems simple enough. Okay, next we have quotient identities. So if I ask you about tangent, what do you know about tangent so far? Tangent of theta is the opposite over adjacent. What else do you know about tangent of theta? Yep, okay. Get away from grass. You're not wrong. Get back more on the unit circle. It's y over x. Tangent is y over x, right? If we rotate to an axis, we have to remember that formula. Well, what was y? Y is cosine. No, y is sine. Hold on. Now I'm confused. Stop. Yes. Tangent is, that's what we're writing. It's y over x. Y is sine. Cosine is x. Right? Y over x. Makes sense? See it? So what would cotangent be? That's it. So what you're building is a library of identities. At Northeast, Mr. Kemp calls these k-tides. I don't think he ever explains what k-tides means anymore. But when he taught them when I was in high school, that stood for, let me just write it down because maybe you'll see it. K-tides. Anybody have a guess what that stands for? Anybody? It means know these or die. Okay? So you're building a library of things that you're going to have to memorize. All right? Just like I told you, there's something you got to know about the unit circle. We're fixing to learn a bunch of identities that we're going to be using to simplify expressions. These are the first 5. The reciprocal identities and the quotient identities. And even though we didn't write these down, we also could say that sine is 1 over cosecant. Cosine is 1 over secant. And tangent is 1 over cotangent. I want you to add those to the reciprocal identities because I'm pretty sure you might need those in the Northeast assignments. Right? I mean, they still fit the same idea. They're reciprocal identities, but that would get you all 6 of the reciprocal identities. Can you guys remember going over the Pythagorean identity? The first one? What was it, if you remember it? That's it. Sine squared plus cosine squared equals 1. All right, we found that by looking at a triangle on the unit circle. If I were to draw this triangle that has a radius of 1, I told you this side length is the adjacent. This one is the opposite, okay? And then we said, because sine would be the opposite over 1, that just means sine is the opposite, right? And similarly, because cosine is adjacent over 1, cosine is the adjacent, and so we could do the Pythagorean theorem to this triangle. Sine squared plus cosine squared equals 1. And so that's our first Pythagorean identity. We did a little bit of work with it already. I don't know where they want that written. It's somewhere. In the unit circle, x equals cosine, y equals sine. And so x squared plus y squared is 1. So sine squared plus cosine squared equals 1. There's a Pythagorean identity. Okay, now there are 3 of them. So again, you can go about memorizing all 3. This is the only one I have memorized. It's sine squared plus cosine squared equals 1. And like right now, honestly, I couldn't tell you what the other 2 are. I know how to find them, and I'm going to show you how to find them, but I don't know them right now. So if I want to find the next Pythagorean identity, I'm essentially changing where the value of 1 is at. And so in order to do that, I'm going to divide everything by sine squared. Because if I divide this first term by sine squared, I know sine squared divided by sine squared is 1. So to find the next Pythagorean identity, let's divide everything by sine squared. This looks awful. Is that okay? Can you say that? I'm sorry I wrote all those words. I'm not really sorry, but it doesn't look very good. Okay, I've already given you a hint. What's sine squared divided by sine squared? 1. What is cosine squared divided by sine squared? It does. We just looked at an identity for cosine over sine is cotangent. So cosine squared over sine squared is cotangent squared equals what's 1 over sine squared? Cosecant squared, right? Another reciprocal identity we just looked at. 1 over sine is cosecant. This is the second Pythagorean identity. And so we've got 1. Sine squared plus cosine squared equals 1. There's the second one. 1 plus cotangent squared equals cosecant squared. You see where that comes from? Now, could you find the third Pythagorean identity? Any you would find? That's it. And so sine squared divided by cosine squared is sine over cosine is tangent. Cosine over cosine, 1. And 1 over cosine squared? This is cosine of 75 degrees. Yeah, that's your fancy calculator. I don't want that answer. We'll get there in a second. It's what?
0.2588.
Good enough. Okay. Now, find a pair of angles that are around the unit circle. Because the problem is, could we do this on the unit circle? No, because I don't know that angle on the unit circle. But could I come up with 2 angles that are on the unit circle that either add or subtract to be 75? What would they be? That's 1. If I added 30 degrees and 45 degrees, that's the same as 75, right? So in your calculator, try cosine of 30 plus cosine of 45. What did you get when you did that? 1.573. Blah, 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 blah. So if I were asked to find cosine of 75, could I just find cosine of 30 plus cosine of 45 and add them together? No. It ain't work. It's not it. Now, why are they making us do that? Because, guess what? When we start working these problems, guess what I see people do every time? They try to do that. They try to make it work. All right, so they're starting by showing you the mistake some of you are going to make. All right, that's what they're showing. And they're trying to make you see it ain't work. Okay? Here are the formulas you can use when I'm adding or subtracting. So, for example, right here, cosine of 75, we could write that as 30 plus 45 in the argument. You follow that? 75 is 30 plus 45. If we wanted to simplify cosine of 30 plus 45, we would have to do cosine of 30 times cosine 45 minus sine 30 sine 45. I can do all of those without a calculator. It might take us a little time. I can do all of those without a calculator and then get the same thing as cosine 75. So you can see these are called sum and difference formulas. The way I remember them, because again, these are all some you're going to have memorized. Katods. Know these are die. If sine is being added or subtracted, the sign between them matches. Right? So if it's addition, I put an addition. If it's subtraction, I put a subtraction. And sine alternates. Sine, cosine, cosine, sine. I don't know how they wrote it. Yeah, that's the way they wrote it. Some people do sine, cosine, sine, cosine and switch the angles. I keep the angles in the same position. That's the way I write mine. And I switch sine and cosine. So sine matches the SIGN sign between them. And then we alternate sine, cosine, cosine, sine. Cosine has the opposite sign, SIGN, between them. If it's addition, I subtract. If it's subtraction, I add. And then it's back to back. Cosine, cosine, sine, sine. Cosine, cosine, sine, sine. See, I did that. I didn't even look. Did I prove it to you?